Good evening, everyone. Jeffrey Ford coming to you December 10th, 2025. You know, we've headed down a very long, complicated road here. This reason I'm doing this now, finally, is several fold. Um, when I was first active as an advocate in the mid to late 90s, I was uh, angry at the government. I was full of fervor. I had some good people supporting me. I had some bad people undermining me. And essentially, I got to the point where um, we got all we were going to get. The spin doctors were ramped up. Media attention was waning. Um, 9/11 came. The war on terror began, and people's attention changed. I went on with other things, and in hopes that the groundwork that had been laid would result in what was needed to get us where we needed to be. Um, a lot of that did not happen, and some of the bad players that were involved early on found a good vacuum to thrive for a number of years. And so we essentially have gotten to a point where there was a lot of bad science, a lot of bad intentions initially, that are now propagated and solidified. It seems like every day there's another YouTube video pops up about the Gulf War Syndrome conspiracy. And all they do is they rehash the same bullshit: shots, pills, gas, whatnot. And they do not substantiate any of their claims whatsoever. Okay? The same problem we had with the federal government back in the late 90s, in the 90s. They made claims that they would not, could not, and did not ever back up. What I'm hoping to do is establish some trust and some authority to begin with, in that when it gets to the time where things are really going to matter, you'll say, I've been watching that guy. He knows what he's talking about. He's done the homework and he can prove it. With that said, which screen am I? Oh, I'm supposed to be on here. Not that one, that's for sure. Um, Back in the 90s, the CIA and the Department of Defense said they would model Kamasi and other events, the chemical events, depleted uranium, any kind of exposures that potentially could harm and has caused trouble with our troops. Um, how they made those decisions on who and how, to what extent those things were going to be modeled. Basically, the CIA hired the CIA to do it because they said we're the only ones with the expertise. So there was little to no independent investigation whatsoever. There was no peer-reviewed scientific panels until after they had finished and written their case narratives, and then they refused to acknowledge or make changes with their reports. And finally, they in 1999 they abandoned trying to model any of it at all. They just said it was going to be too difficult. There was too many uncertainties. Well, the uncertainties were there because there were certain things that they didn't want known. And so when you don't want the truth, you just don't look at all the possibilities. So essentially what they ended up doing was taking some mathematical models and plugging in some numbers and seeing what came out. They weren't based in any actual meteorological climate, terrain. They weren't based in anything that actually were going on at the time during this period in the place at Camisea. They were basically computer models that really didn't have a tie to the reality of the situation. Now, did they have the data and the means to do so? Of course they did, because there's no new information. I get this. What I'm working with is not new information. What is new is that I have since learned of it and learned how to use it. Had they wanted to use this then, they could have, but they didn't because, again, it would have shown what they didn't want shown. So what we're doing today is um, this is satellite information from NASA. The Goddard Earth Observing System model, the GEOS, has been up there. There's many versions of it. It's been up there since 1980. Okay? Flies around the planet hourly. So every day in every spot on the planet, there's an image. So it flies this whole planet, or I should say, the the planet flies under it. There's different types of orbits. There's geostationary, there's geosynchronous. I'm not going to get into all that. Don't need to, unless you want to get a degree in remote sensing and GIS like I do. Safe to say that every day this satellite flies around the planet. And so you've got hourly, time average, single level assimilation diagnostics. And what that does is the different things that it picks up is product specifications, hourly, timed average at a certain latitude and longitude. It flies and picks up eastward wind component, in other words, winds that are moving to the east, and winds that are moving to the north. So, in other words, you've got two positive direction potentials, 180 and 180. If you want the south and the west wind, you do zeros. See how that works? Because it's the opposite. So if you're in the middle, you're at 90. You got air temperature, and for each time of day, you have bands. Now, that satellite information comes in formats that then must be converted into different GIS programs and geographic information systems so that it can be used and manipulated in ways that then we can interpret it. So what I'm doing here is I'm using the software QGIS, which is open source. It is like, if you know anything about it, Esri. Um, it's the same stuff that Google Earth and all those places use. So, you pull up your phone, you're looking for somewhere to go on your map. It's all kind of the same stuff. Now, I've been working on this particular map for several months. I've already gone through intelligence documents over the last year and reconstructed troop locations. And as you can see here, they are the yellow dots. I'll turn on the labels. You can see start showing up. I'm going to make sure that I'm showing the right screen. Yeah. Um, turn on the labels. You can see that I've reconstructed from DoD, CIA documentation from their reports back when they were kind of open about wanting to get to the bottom of things. They provided some troop locations. Do they have an entire database that is down to the company level now? Yes. Are they going to let me into that? I seriously doubt it. I seriously doubt it to the point that I'm not even going to bother asking because I'm not going to waste my time. What I have is enough that I can show you right where um, come see it. I can turn on the roads. There's the roads. I can show you the canals. Um, so with that said, oops. This is how I take the point data, which is in the form of comment, comment delimited text. In other words, it's on a note card. All the coordinates and the unit locations and such, and then put it on the map, and then I can go here and I can turn the labels on to the labels. And so text, make it a little bigger, and like this. And what we want is unit designation, which I assure you, it was not easy going through and getting every single unit, the company, the parent unit, all defined where it would be then usable and accurate. That's the main thing. So as you can see here, I have plenty of troop location information. There's the 307th Engineer Battalion. There's involved 3rd Brigade, 1st Brigade, 18th Airborne Corps, 82nd Airborne, uh, the Marines, the British, all the task force, the 24th ID, 7th, um, everything that it's not accurate. I mean, it's not complete down to every single unit because there again, I don't have privy to that exact information. What I've done is basically reconstituted it from um, documentation, and in a sense, it's actually more, uh, from what I found, is more accurate than mu much of what I've seen from the Department of Defense given out publicly. So anyway, moving on here, because that's not what I really want to emphasize on today. It's troop locations. I've already talked about that before, and I'll talk about it again. It is important, but what I'm showing today is even more important because um, every few days I have a breakthrough, and today I had another one because there are so many different satellites, and they sense different things, and they sense them in different ways. And we're talking about 30, well, 33, 34 years ago now. I have to find the satellite data archived from the agency that's holding that data. I have to be licensed to get it, and then I have to download it in a format that I can use it, and then it has to be converted. And that's not easy. And fortunately, I use some AI to help me write some of the scripting that I use in order to do it. So to get to these, um, to convert these files into from math into dots and lines, there has to be some conversion and to images. So I've already started this process and it's not easy because if you look here, scroll up. Let me make sure I've switched. I didn't switch. not really great at then being able to do anything with them. So now you can see um, this is called Panoply. This is how the data comes to me, and it has all these different channels on it. Okay, brightness, temperature, um, cold target noise equivalent temperature difference. Um, but when it comes down to it, there's really only a few things on here that you actually see. The rest of them are what it went into to make what it is that you want to see. So on this one, we're going to look at brightness, temperature, I believe. So then we're going to have it create a plot. And that one, see, that's the other trouble is some of these have already been used by agencies, and so they've clipped things out of it. And in doing so, it renders it not very useful, such is the case with this particular satellite. So let's go up here. Let's pull out. Um, let's do this one. Surface normalized downdwelling shortwave radiation. And let's see what that looks like. Well, not on that band. We won't. Let's see. Uh, that's the difficulty in messing with all this stuff is you don't know what you got until you open it all up. Okay. Open this one. We're back where we were. Brightness. Crap. Yeah. Well, anyway, let's get back to what I was doing and focus on what we're doing here. Because I've got to. Well, I'll tell you why. What I've found. All right. So turn off some of this stuff. Turn the rows off. Turn off the units. These number values and these arrows is wind direction and speed, and that speed is in meters per second. So every second it's right around Camasia about 2.9 meters per second, which means in 1 hour, uh, let's see, here's the table. Uh, 3 meters per second is going to get you about 10 kilometers an hour. So it's not very far, it's not very fast. And at 2:30 in the afternoon on March 4th, 1991 at Camasia, these are the wind speeds and these are the direction values. So, as I've been trying to say, the wind was blowing to the south-southwest, and now I've proven it. And why is that important? Because here's where the troops were. And there's the plume. There's the Camisea is right up here, right in there. And so what do we have happening is for the first hour, I have computed the plume, speed and direction, taking into consideration the contours and the terrain. And this terrain mapping that was taken on that day. So this is the ground at Qamishli in Iraq in 1991. I think I'm not sure if it was if it wasn't exactly March 4th, it was that week because that satellite doesn't spin everywhere every day. And that was and I'll go quickly show you how that looks. And I just do that by unchecking all these layers. So actually, let's see. Let me go back here. Whoops. So that was gotten by satellite images such as this. And that is in grayscale. So if you zoom in, um, I have to get all the tiles. I can't remember which ones are which now. Anyway, um, here's the oil well fires. It's pretty accurate. I mean, it's not extremely detailed, but it's enough. Here's the mouth of the Euphrates. So, so you take a whole bunch of these, um, and actually, let's see. I'll show you it real quick. And I want you folks to see this stuff so that you understand that there's actual science behind it, and I have no problem showing you or explaining what that science is. So I take all these individual satellite photos of the ground from that time, and then through a process which took several days, several, probably a week or more for me to figure it out. Then those are all smoothed together into a layer that looks like this. And I don't know why it's looking weird like that. I think I've messed something up on it. I hope not. Anyway, that is not what I had. Yeah. Gotta mess the symbology up on that a little bit. Anyway, so from that, then a hill shade is made. Somehow by turning everything off. Oh, there. Which essentially the computer reads the yeah. Anybody who's knows anything about GIS would look at my files right here and say, "Man, you have got an absolute mess." I tend to agree. From those digital elevation models, we can come up with contours. See how that's done? And the computer reads the variation in the grayscale. And then from that, I can extrapolate the contour lines. And from then, those contour lines can be then used. As soon as I figure out how I messed it up. And then from that also, I put in this hill shading. So let's see. Trying to get back to where we were. There. So that gives us an idea of what the terrain is really like, or was really like at that moment. Why is this important? Because as that plume grows, and the wind moves along the ground, it is affected by elevation. So it starts out right here, and eventually and see I have is not just the wind direction and speed for Camisea, but the entire planet at the same time. So uh, All right, back to what I was doing. I wanted to just jump on here and make a quick video. It never works that way. I'm finding out. And load it in here. And so that's converting these files into usable format. It's not just pictures. They're pictures loaded with lots and lots of information. And so those pictures with all that information have to be brought together. So now I can go up here and I'm going to turn off some of that stuff, and I'm going to go up here and I'm going to bring in some of those layers that I just converted. If I can remember where I put them. They are the downloads. Right there. So let's see. This is the nuts and bolts that I wanted to show you. What we're going to do here, let's see. Now I've got the FOD. Okay. So let's see. I'm on. And run it, and it probably won't work. Yeah, let's see. All levels processed. Syntax error. Yeah. So then I put it back in the AI, tell it where it messed up, because I don't have enough years left to sit here and figure out all this Python coding. Right. Let's see. Paste the entire. Let's see. Oh, to the panel. Oh, it appears it put some in and some it didn't. And it was just one of the files. So it looks like there was a couple files that I had not done a process of this and that. So now go back in. Well, there's one layer that's still not finding for some reason. Yeah, it wants me to create a whole bunch more. I'm not going to do that right now. So anyway, I go to the file. I have to set the coordinates for the ones that it did load. And from there, let's see, we've got the wind at 2 meters above the ground. The one that I've already done is 10 meters above the ground. And this one is at 50 meters because what I want to do is see the difference in the directions. Processing toolbox. Field calculator. 50. And excellent. So that one worked. So now we will, that gave us our direction. So now we're going to go in and do speed. All right, and this is how I came up with this wind speed and direction from earlier when I first started the video. These right here. That's at 10 meters above the ground, which is about the height of a one-story commercial office building. But now what I want is I want to know, let's see. If there's a difference. So let's see. So I changed the values there so that we can see them better. And the symbology as well. So this is the height difference in the wind between 10 meters and 50 meters. And I'm not seeing a lot of difference in the direction of the arrows. So let's see. Click that off. The arrows are all still pretty much going in the same directions. But the values are different. The values, which makes perfect sense, the values at higher levels, at 50 meters, are higher than they are down low. So if I was to put in the wind levels at 2 meters, it would be even less. So if you just imagine anytime you've seen a big fire somewhere and the smoke's going up in the air, the top of the cloud is moving faster than the bottom because the higher you go in the atmosphere, the higher the winds. So right here, now I'll pull this back up to where uh, so turn the labels back on so I can go in here and I can look. And you can see there's the canal position, 307th Engineer Battalion, Alpha, 37th Engineers, everyone who was at or near Kamasee at the time. So that's their location. So at near 10 meters off the ground, the wind was blowing 2.6 meters per second. At 50 meters off the ground, which is, you're talking now, 10-story building up. And I'll show you why that's important because um, because there we go. This is Calmacia at about 2:30 in the afternoon on March 4th. 10 meters would be right in there. 50 meters would be up here. The CIA said this cloud was going to from right to left on my screen. We know that it was not. They said it was moving this direction, that direction, the opposite direction of these arrows. Okay. Because in that direction, in the opposite direction, there was no troops. And so they didn't have to model or deal with the exposure of all these units that were still here on March 4th when that bunker blew up. Because what I do now is from that I can now start tracing my plume footprint. So in the first hour, and now you tell me that that big red blob there is that. Now that I have the wind direction and I have the wind speed and I have the terrain and I have 4 or 5 other satellites that I can show temperatures, the oncoming storm front, all sorts of things that add to determining exactly what happened on March 4th and who was exposed. Because it's going to completely change everything. Because there again, if you hadn't seen the other videos, they refused to model this day, and then instead they modeled an event that was 6 days later when all these troops, when a lot of these troops were gone. And then the models that they used, they were just math models. Now, you say, okay, you've just converted all these files and you're using these scripts, yada, yada, yada. Aren't you just using math models? No, because this is data that came directly off of a satellite that is looking down into the clouds, into the temperatures, into the layers with very sensitive equipment from NASA that detects actual physical parameters at a specific point in time and space. That is not the same as a model that only tries to replicate what might have been seen. Models are what you use when you don't have this data. It's when you say, well, here's our best guess. This is not a best guess. This is the conditions that were present. The only thing I'm guessing is, does this footprint resemble this explosion? That's pretty simple, right? When you think about it. And I have 5 to 50 other ways of determining what was in this cloud, what blew up that day, and where it went, and who was exposed. Because it's going to take weeks and months probably for me to load all the videos up to try to explain what really happened here. But I'm just trying to um, load them and do them as I go because it's a big story. And what we're doing right now, when you see this on CNN and the front page of the New York Times in a few months, and they're having Senate hearings about it again, and there's this big deal in the news about how the CIA lied even more than we thought, you'll say, well, that guy's telling the truth because he could back it up. I won't put anything out here that I cannot back up.